Hello everyone. So in this video we will discuss the basics of signal. So even if you know the basic of signal, just watch the video completely. You can watch it on 2x or you can watch it skipping the video, but just watch it completely because there would be something that you don't know and that would be very important. Okay, so just watch it, just try to watch it completely. Okay, so what is a step signal? So in case of step signal, what actually happens is, what do we know? We know about DC, right? DC is like this. Let's just call DC 5 volt. So that means it is coming from minus infinity to infinity for complete part, right? But in case of step signal, it is only from 0 to infinity. Okay, so if it is written as AUT, that means you are getting A for t greater than equals to 0, not greater than equals to 0, I should write for t greater than 0, and 0 for t less than 0. Actually at t equals to 0, we can't really define it. Some people write a by 2 because this is how the graph will look like. For t less than 0, it is 0, right? For t less than 0, it is 0, and for t greater than 0, it is a, right? From 0 to it will go to a. So this is what a step function mean. Okay, what does a step function mean? You are coming from minus infinity, it is 0 0 0 0 0 0, suddenly you get a 0, all of a sudden you are getting a. Okay, so this is your time t equals to 0. So if it is written AUT, that means first you are having 0 value, then suddenly you are getting a value. If, like, let's just assume your VT is 5 UT. If your VT is 5 UT, that means previously there was no voltage in your circuit. Suddenly you are applying a 5 volt. Like your circuit was like okay, but suddenly you see 5 volt, right? So this is what it means. Okay, so t equals to 0, you are suddenly giving a input. Okay, let's see impulse signal. Okay, so we will see the deep meaning of impulse signal. First, let's just see what it is. So xt is a delta t. This is written. This is the impulse signal. So at t equals to 0, it gives you infinite magnitude, and at t equals to, for not less than 0, it is always 0. So it is defined only at t equals to 0. If it is written delta t, that means it is defined only at t equals to 0, and it will give you infinite magnitude. So what is this a? This a is the area. Okay, and the magnitude is infinity. So how do you show it? You show it like this. Okay, and you write a here. So this a represents the area. Okay, we will see the deep meaning. Okay, this a represents the area. So what is the unit of a? Unit of a will be, that will be unit of xt, okay, multiply by unit of t. Basically this a is written, we actually write it like this, a delta t. Okay, so if it is written a delta t, that a shows the area, and what is the area? Unit of xt into unit of t. Okay, let's just see the actual meaning of impulse signal now. So what is impulse signal? At t equals to 0, you will have infinite magnitude, like very large. The value of xt is very large at t equals to 0. But after or before t equals to 0, there is nothing. Okay, at t equals to 0, you are applying very large amount of voltage or very large amount of input, but before and after there is nothing. Okay, so this is what impulse signal is. And if this shows a value, that is not magnitude, that is the area. Okay, so what do we actually mean by that? Let's just see. So actual meaning of impulse signal. So let's just assume there is a circuit and you have to deliver 4 coulomb charge. There is a circuit and you have to deliver 4 coulomb charge in that. So you know that your q is integration of it into dt, or you know that like your it is dq by dt, right? Your it is qt by dt, right? So your q is integration of I to dt from minus infinity to infinity. So you have to give 4 coulomb charge, right? You have to give 4 coulomb charge. So what you can do, this is my time span of 1 second, right? This is 1 second. So for 1 second, for 1 second, I am giving 4 ampere current. 4 ampere current. So my Q will be 4 into 1. That means 4 coulomb. So basically this area is what? This area is 4, right? This area is 4. So that represents 4 coulomb. What is the unit? Like I shouldn't write 4 coulomb. I should write 4 ampere into second. Unit of IT is ampere, unit of time is second. So that means it is 4 coulomb. Okay. Now let's see what I can do. Now what I am doing, I am decreasing the time. Okay. Decreasing the time. So now I will give some amount of current for half second only. So for giving 4 coulomb charge, how much current I should give? Tell me. I have decreased the time span. So how much current I should give? 8 ampere, right? I should give 8 ampere current, so that 8 into 1 by 2 equals to 4 coulomb charge. Decreased the time span. Decreased the time span. That means increased the value of xt. Now I am decreasing the time span more. Now what is the time span? Time span is only 1 by 4 second, right? Here the time span is only 1 by 4 second. Let me make it more clearer. So here the time span is only 1 by 4 second, right? So how much magnitude do you require now? Tell me, what should be the magnitude to give the same 4 coulomb charge? How much magnitude should be there? 16, right? 16 ampere should be there, because 16 into 1 by 4, that means 4 coulomb. So as I am decreasing the time span, I have to increase the magnitude. First my time span was 1 second, my magnitude was 4 ampere. To give the same amount of charge, in 1 second I am giving 4 ampere. In half second I am giving 8 ampere. In 1 by 4 second I am giving 16 ampere. Now what if I take my time equals to 0? In no time. 1 second 4 ampere, half second 8 ampere, 1 by 4 second 16 ampere. Right? Time is 0. That means IT will go to infinity. Very less. IT will go to infinity, but area is the same, 4 coulomb. So if I have written IT equals to 4 delta T, IT equals to 4 delta T. So what does that mean? What will be the unit of this 4? 4 delta T, what will be the unit of this 4? This 4 is ampere into second. That means it is coulomb. Right? That 4 is coulomb. That means you are giving 4 coulomb charge in no time. That means you are giving 4 coulomb charge in no time. Okay, here what was happening? You are giving 4 coulomb charge in 1 second, right? You are giving 4 coulomb charge in 1 second. Here what was happening? You are giving 4 coulomb charge in half second, and here you are giving same 4 coulomb charge in 1 by 4 second. So as you decrease the time span to give the same amount of charge, the magnitude of current is increasing. So in this case, you are giving 4 coulomb charge in no time, right? You are giving 4 coulomb charge in no time, but the magnitude of current will increase very largely. So this is what infinite current means. If I am saying my IT is 10 delta T, that means I am giving 10 coulomb charge in no time. If I am writing my VT is 5 delta T, what does that mean? Just think about it. VT is 5 delta T. I have told you one thing, EMF is equals to d phi by dt, right? That means voltage is equals to d phi by dt. Phi is the flux, right? Phi is the flux. That means I am giving 5, what is the unit of flux? Actually, I also forgot, I need to check. Yeah, so actually unit is not our matter of concern here. So basically it is like I am giving 5 amount of flux in no time. If Vt is 5 delta T, that means I am giving 5 amount of flux in no time. Just as It is equals to dq by dt, that is 5 delta T, that means you are giving 5 coulomb charge in no time. Are you getting it? Are you getting it? Why charge only? Because it is ampere into second. Ampere into second will give you charge. In the similar way, if I am writing Vt equals to 5 delta T, that means it is volt into second. Volt into second will give you flux. That means I am giving 5 amount of flux in no time. Are you getting it? If I am writing, let's just assume I am writing something, let me think. Just assume I am writing something xt equals to 5 delta T. Xt has a unit of kg. It doesn't really seem fine, but yeah, any unit it has. Okay, so like what is this 5? This 5 will have a unit of xt into unit of t, right? 5 will have unit of xt into unit of t, right? So basically you are giving 5 amount of that value in no time. So here you are giving 4 coulomb charge in no time. Are you getting this point? I hope you have understood this point. Okay. So this is the actual meaning. Like the magnitude is infinity. Why the magnitude is infinity? Because you are giving it in no time. That's why the magnitude is infinity. Okay. If you are giving slowly, like in 1 by 4 second you are giving, so the magnitude was 16 ampere. If it was 1 by 8, the magnitude would have been 32. If it was 1 by 16, magnitude would have been 64. But if it is 0, the magnitude is infinity. So you are giving very large amount of current. Why so? Because you are giving 4 coulomb charge in no time. Like It is equals to dq by dt, right? So this dq is 4 coulomb. You are giving 4 coulomb charge in no time. Time is 0. Value will be infinite. 4 coulomb charge in no time. dt is 0. 4 coulomb charge in very less time. So the value will be infinity. So the value is infinity. But if it is written 4, that means it shows the area. And area means it is showing ampere into second. So this is the actual meaning. Are you getting it? Okay. So this was the most important part that I wanted to know you all. Okay. I wanted all of you to know. Okay. So let's just see our third signal, that is ramp signal. We will come back to this point again when we study the differentiation. Okay. So we will discuss it more. I will discuss it more. So first let's see ramp signal. What is ramp signal? Ramp signal is simply the straight line passing through an origin. Okay. With a slope. So if it is written ART, that means it is the straight line passing through the origin with a slope of A, but the difference is that it won't be there for t less than 0. It will always be there for t greater than 0. So for t less than 0, it is always 0. Okay, it is always 0. For t less than 0, it is always 0. Okay, and the slope is, this is the slope. So the slope is a. Okay, basically if ART is written, that is AT into UT. If there is if somewhere UT is written, that means they are eradicating the part before t less than 0. Let's just assume written 5 UT. That means it is basically the multiplication of 5 and UT. So this value will be multiplied with 0. So this will be 0 only. After that, this value will be multiplied with UT. UT is 1. So it will become 5 UT. So that means if somewhere UT is multiplied, that means the value before t equals to 0 is gone. So for value for t less than 0 is gone. Only for value t greater than 0 it is there. Okay. This is what it means. Okay. So let's just see the differentiation of a step signal. So if you differentiate a step signal, you will always get a what? Impulse signal. Why so? Why so? Because again I have written the example of the charge and the current. Okay. So what is happening here? So 0, 0, 0. Okay. Everything was 0. IT is basically dq by dt. IT is dqt by dt. Okay, so previously it was all 0. Suddenly at t equals to 0, from here to here if you go, you are suddenly having 5 coulomb charge, right? So at t equals to 0 minus to 0 plus. So from t equals to 0 minus to 0 plus, you are having 5 coulomb of charge, but the time is 0 only, right? From 0 minus to 0 plus, the time is 0 only, and the magnitude is infinity. If infinite magnitude is there, that means there will be impulse, right? If infinite magnitude is there, that means there will be an impulse, and this is the impulse. Okay, so this is the impulse, and we will write it as 5 delta t. This value shows the charge, shows the charge, shows the charge. Okay, this 5 shows the charge. Are you getting this point? Now differentiation of ramp signal will give you step signal. Okay, just like differentiation of step signal is giving you an impulse, differentiation of ramp signal will give you a step. Have you understood this point? From 0 to 5 we are going in no time, that means there will be an impulse of 5 delta t. Okay, I hope you have understood this point. Okay, and differentiation of ramp signal will give you step signal. Yeah, so this is the simple derivation. Okay, no, like very simple derivation. So this is my ramp signal ART. I can write it as AT into UT, right? Because what is the graph of t? The graph of t is like this. But if UT is written, that means this part will be gone. This part will be gone. Only this part will be left. This part will be gone to 0. So A into T into UT I have written. Okay. Now I will differentiate it. A is the constant. It will be outside. But now there are two signals. Okay. Never take this as one signal only. Like many times I have seen, like people write, what is the differentiation of this? They will forget this. Differentiation of this will be 1. So your final answer is UT. That is correct, but luckily the method is wrong. Okay, the final answer is correct, but luckily it is correct only. Okay, the method is wrong. Okay, why so? Because there are two time domain signals, T and UT. So if you differentiate both of them, A into, what is the, we are applying U into V rule, T as it is, differentiation of second. What is the differentiation of UT? Differentiation of UT is delta T plus second as it is UT. What is the differentiation of T? That is 1. So this is what you get. Now what is the value of T into delta T? Tell me. T into delta T. This is your T, right? And this is your delta T. Delta T only exists at T equals to 0, right? Delta T exists at T equals to 0 only, right? Delta T exists at T equals to 0 only. What is the value of this function at T equals to 0? It is 0. So T into delta T will always give you 0. Are you getting this point? T into delta T will always give you 0. Why so? Because at T equals to 0, delta T only exists at T equals to 0, and at T equals to 0, this function is 0. So T into delta T will always give you 0. Are you getting this point? Delta T exists at T equals to 0 only, and at T equals to 0, your function T is 0. So it will give you 0 value only. Okay. So finally your answer is AUT. So basically if you differentiate it, this is the graph and slope is A. If you differentiate it, you will get as final value as this step. Okay, 0 was there, differentiation of 0 is already 0. Differentiation of 0 is already 0. But after that you will get a step. Okay, the value of that step would be A. So basically RT will be replaced with UT. So you can write this thing, d by dt RT is equals to UT. Okay, d by dt RT is equals to UT. A is constant, that is outside. Okay, so now basically if you go from impulse to ramp, if you integrate them, like ramp, differentiation of ramp is step, differentiation of step is impulse. So if you integrate impulse, you will get step. If you integrate step, you will get ramp. Are you getting this point? Integration from 0 to T delta T ut, sorry, delta T dt by ut, delta T dt will give me ut. From 0 to T, why I am writing, I can write minus infinity to T, y 0 to T, and here you can also write from minus infinity to T ut dt will give me RT. Okay, so this is for integration. For differentiation we have already written. Okay, now we are generating a step signal. Okay, we will generate a step signal. How we will generate? Because we have always DC. What is DC? DC is this. We have 5-volt DC battery. That means it will always give you 5 volt. But now you want the circuit to give 5 volt at a particular time only. बैटरी मार्केट से खरीद के लाए, वो हमेशा 5 वोल्ट देगी, बट एक पर्टिकुलर टाइम पे तुम्हें 5 वोल्ट चाहिए. यू नीड 5 वोल्ट एट ए पर्टिकुलर टाइम. सो हाउ विल यू गेट दैट? What you will do, you will turn on the switch at t equals to 0 only. You connected a battery, but you turns on the switch at t equals to 0 only. So what is happening here is that, like before t, this can be a ground, this can also be a ground, this should be given actually, this is a ground. Okay, and the network doesn't have any energy source. So what is happening? For t less than 0, what will happen to V0? V0 t will be 0 volt. And for t greater than 0, what will happen? This will be shorted, so complete 5 volt will come across V0 t, right? So V0 t is 5 volt. So this is what V0 t will be 5 ut. This is your tap signal only, right? So V0 t is 5 ut. From 0 to 5 ut goes. This is your V0 t. Okay, from 0 to 5 volt. Are you getting this point? Now this is one interesting problem. So tell me what will happen here. So for t less than 2 seconds, this is grounded and this is also grounded. For t less than 2 seconds, your V0 t will be 0, and for t greater than 2 seconds, your V0 t will be 5 volt, right? So basically how will your graph look like? How will your graph look like? This is 2 seconds, right? This is 2 seconds. So for t less than 2 seconds, V0 t is 0. For t less than 2 seconds, V0 t is 0. And for t greater than 2 seconds, it is 5 volt. that is 5 volt. Understood? For t less than 2 seconds, it is 0, and for t greater than 2 seconds, it is 5 volt. So how will you write it in terms of ut? Can you think of it? How will you write it in terms of ut? Try thinking of it. Pause the video and try thinking of it. Okay. So how will you write? If you have already studied signal system, it will be easy for you. But those who haven't studied the signal science system, I want them to write. It will be 5 ut minus 2. Got it? How did I write it? Look, it will start from t equals to 2 only, no? What will be the value at t equals to 1? V naught 1. It will be 5 u of minus 1. What is the value of u of minus 1? Ut is what? Ut is 1 for, ut is 1 for t greater than 0 and 0 for t less than 0. That means u of minus 1 will be 0. And this is what you expect, right? This is what you expect, right? What will be the value at t equals to 3? T equals to 3, V naught 3, that will be equals to 5 u1, that means 5 volt, and this is what you expect, right? u1 is 5 volt. So so there is one thing, one common concept that you study in signal system. If you have already studied signal system, it would be easy for you. So whenever there is a right shift in the signal, my ut was from 0 to infinity. Whenever there is a right shift, you subtract it, t minus 2. If there was a left shift, you would have written t plus 2. Okay. So if there is right shift, that means u t minus t naught. And if there was a left shift, you could have done u t plus t naught. Okay. So just make the graph and then you will be able to realize. Okay. So just I can think of a question. Okay. One backup question. Write yt in terms of impulse signal. Now what is your yt? Yt is something like this. Yt with t, and this is your yt. It is written 5. Okay, and this is t equals to 2 seconds. What is your yt? Tell me. What is your yt? This is just a backup question. Okay, not a main question, just a backup question. Tell me, what is yt? It is 5 delta t minus 2, because delta t is at t equals to 0. If there is a right shift, I would do t minus t naught. If there was a left shift, I would have done, okay, I can do one more thing. I can put a 4 here, t equals to minus 2. So tell me, it will be plus 4 delta t plus 2, because there are two signal. One is at delta t is always at t equals to 0, but if there is a left shift, if there is a right shift, I would write 5 t minus 2. If there is a left shift at this side, I would write 5 t plus 2. Okay, so whenever there is a left shift, जब भी उल्टे जाते हैं हमेशा पॉजिटिव कर दो. उल्टा जाना पॉजिटिव नहीं है, बट जब भी उल्टे जाते हैं, नेगेटिव की तरफ जाते हैं तो पॉजिटिव कर दो, और पॉजिटिव की तरफ जाते हैं तो नेगेटिव कर दो. ठीक है, उल्टा करो अपने. ठीक है, इस केस में केवल. ओके, सो व्हेनेवर यू आर गोइंग टुवर्ड्स नेगेटिव, जस्ट ऐड देम अप. व्हेनेवर यू आर गोइंग टुवर्ड्स positive, just subtract them up. Okay. Okay, then can you tell me what will be V naught t here? What will be V naught t? First, understand the switching position. So for t less than 0, tell me what is happening for t less than 0. this will be open circuited, right? This will be open circuited, and this will be short circuited because at t equals to 0 it is opening. In the previous video we have studied this concept. It is written like this, that means it is opening at t equals to 0, that means it is closed before t equals to 0, right? That means it is closed before t equals to 0. Closed before t equals to 0. This battery remains there, that doesn't really matter. This battery is here only, but that doesn't really matter. क्या हो रहा है यार? This is grounded, this is grounded. So this 0 would come up here. So your V naught T is 0 volt. And for t greater than 0, what is happening? For t greater than 0, what is happening? This switch will be open, this switch will be closed. This will be your direct V naught T. So basically this node is 5 volt, this node will also be 5 volt. This node is 0, so this node is 5 volt, so V naught T will be 5 volt. So your final V naught T is 5 UT, right? Are you getting this point? So your final V naught T is 5 UT. So that's how you can generate a step signal. Okay, just a switch will make you generate a step signal. Okay, if the switch was open, like in the previous example, switch was open, so V naught T was 0. Just as it is closed, V naught T is 5 volt, like this. Open, switch, V naught T was 0. Just as it is closed, V naught T is 5 volt. So this is how you will make it. Okay, so you will make the switch such as it turns on at t equals to 0 only. Okay, so in the example it will be used. Now this is a very important concept that is not taught anywhere. That's why I will put a great concentration here. Okay, so what is the frequency content in a step signal? Let's just take an example of sinusoid signal. This is my sinusoid signal. It's not looking like an uniform waveform. Okay, it doesn't look like a uniform waveform, but you can assume it, right? Let's just assume there is a sinusoid signal that has a frequency of omega. What is the frequency? Number of cycles per second. Let's just assume in t time, how many cycles are there? One cycle. For this waveform, how many cycles are there? One cycle. Now what I do, I increase the number of cycle in the same time only. How do I increase it? I increase it like this. Okay, it will be very tough to make it uniform. I'm not increasing the magnitude. Okay, magnitude remains same, but frequency increases, right? This is my signal, my frequency is omega. Now if this is my signal, my frequency is greater than omega, because in the same time I am having more number of cycle, right? Let's just assume if this is t only, so in this period I am having how many cycles? 4. Okay, here I was having only one cycle, here I am having 4 cycles. Not 4 actually. Is it 4? 1, 2, 3, 3.5 it is. Okay, so basically your frequency is increasing, right? If you make it like this, so if this was the waveform, your frequency was omega. If this is the waveform, your frequency is increasing, right? If I increase it more like this, if I do like more like this, right? So frequency is increased more, right? Frequency is increased more. So frequency is greater than omega. Now what I do, like here we were having 0 only. Before this we were having 0 only. Okay, 0 only. Okay, let's just call this waveform as, if this was a sine omega t, let's just call this as a sine omega 1 t, and this one as a sine omega 2 t. So what is happening? Omega 2 is greater than omega 1 is greater than omega. Why so? Because in a second there are more number of cycle. If there are more number of cycle, that means frequency is higher. Now what I do, this is 0 0 0, like it is going up to its maximum value in some time, right? Like it, like this waveform was going to its maximum value in this much of time, right? This waveform was going to its maximum value in this much of time, right? This waveform is going to its maximum value in this much of time, right? It is taking some time. Now what I do, I make the maximum value in no time. Previously it was 0, and then I suddenly go to its maximum value. I reach its maximum value in no time. So tell me, what will be the frequency content? What will be the frequency content here? Infinity. Why so? Because there is a sudden jump. Because there is a sudden jump in the value. Sudden jump in the value. Okay, that means for a step signal, omega equals to infinity at t equals to 0. So here we have omega equals to infinity, but at DC omega equals to 0. This is the DC part, right? Basically, if it is reaching to its maximum value in this much of time, it has some frequency. In this much of time, it has lower frequency. In this much of time, it has lower frequency. But it is reaching in no time, that means it has infinite frequency. Are you getting it? More time, more frequency. Lesser time, sorry, more time, lesser frequency. If time is lesser, that means more frequency. If there is no time, that means infinite frequency is there. From 0 to 5, from 0 to some value, whatever we say A, from 0 to A, it is reaching in 0 second. That means infinite frequency. Are you getting this point? Because there is a sudden jump, that means in step function there is a sudden jump, that means in step function there is infinite frequency at t equals to 0. Okay, so this you need to keep in mind. So whenever there is a sudden jump, let's assume we are going from 0 to A, that means there is infinite frequency. If we are going from A to 0 in no time, you are A, suddenly it's 0. That means there is also infinite frequency. Are you getting this point? Very, very important point this is. Okay, so this is the basics of signal that is required in circuit analysis. Okay, like there are a lot more concept about signals that we will study in signals and system whenever we study that topic. So I will teach that topic as well very deeply. I will teach signal system very deeply as well. Very intuitively I will teach. Okay, and here also you are getting the concept. I hope you are enjoying the videos. Okay, so kind of different analysis we will see, and when we study the first order RC circuit, you will just see that it is very different. First order RC/RL. Okay, we won't use Laplace anywhere, we won't use equations, we will just see how the circuit behaves, and you will be able to solve those 5-minute or 10 minutes question within 30 seconds. That I can guarantee, and that too with full confidence. And no tricks are there. It is pure concept. No tricks, nothing. Pure conceptual thing we will talk about. Okay, so I hope you are enjoying the concept. We talked about the frequency content, how there is a sudden jump, that means there is infinite frequency. Then previously we talked about how we actually generate a step signal, because this will be used in the questions, like they will open the switch, they will close the switch, that means there is step signal or not. Because teachers or students don't really take notice like what is happening. They take DC and step same. Many of the students I have seen, that they say that DC and step are same. No, in DC there is no infinite frequency. In step there is infinite frequency. There is a sudden jump. And there is, what does the sudden jump mean? Sudden jump means in no time you are giving that much of value. and if you differentiate it, it will give you impulse. That means very large amount of some value. It can be very large amount of current. So whenever there is a large amount of current, what happens in the circuit? So all these things we will study very, very deeply. Okay. So all I need is your support. We need your support. Just share the notes with everyone or share the videos with everyone. We will study very, very deeply, and we are taking very less time. You would see like there will be hours of lecture, but there is nothing fruitful. We are just taking the thing that is more important to you and delivering it in very less time, also very deeply. So I hope we are doing a very good job. So I expect good response from your side. Okay, just share it with everyone. Just tell them that watch these videos, and like, it will be very helpful for all of you. And also we show the differentiation and integration of step function, impulse function, signals, impulse signals, step signals, and ramp signal. And we studied about them very deeply. What is an impulse? Impulse means you are giving some value in no time. Because of that, you are having an impulse. And this value shows the area. Area means the unit of this will be ampere into second. Okay, ampere into second is charge. Okay, it can be flux as well. Okay, it can be charge as well. Okay, so these things we studied. How do we, what is the actual meaning of impulse signal? All these things we studied. Okay, so in the next video, what we will study? We will study about differential equation. Okay, so if you already know differential equations, you can completely skip the next video. No, not completely, because there will be something that I will be teaching you that is different. Okay, so don't completely skip the video. Just watch it like quickly. Whatever whatever new you learn, you can note it down. Okay, so but just watch it completely, or you can read the notes as well. So just watch the next video completely, like quickly you can watch it. We will just see the mathematics of differential equations. Okay, so in the next video we will study that. Okay, then thank you.